Assalamualaikum warahmatullahi wabarakatuh and a good day for everyone. We are from group 2. My name is Nur Imar Rifat and my partner is Muhammad Shakir bin Najmi and Muhammad Iqbal bin Murtaza. So today we will explain to you about lab 1, control principle and system, which is transfer function and system response. So first I will explain about the procedure that we must do in transfer function and system response lab. There is two parts in this lab session, which is part A is about mechanical system and part B is about electrical network. This lab is basically about using MATLAB and doing manual calculation to find out the transfer function for mechanical system and electrical network. So in part A, which is mechanical system, we need to get the transfer function on G1S and G2S for the given system, which is this one here. This system is translation mechanical system. So the G1S and G2S is what we have to find by manual calculation and also by using MATLAB. So this is the value had given to us, and by using this value we must generate unit step response for both transfer function G1S and G2S. Then we have to use the same value in Simulink software as well to make sure that we get the same value. Next, for the part B, we are supposed to do the transfer function for the electrical network. In this lab, we had been given input VT and output VL, where VL is the inductor voltage. This is the parameter that had been given to us to do the coding in MATLAB and Simulink, and this is the diagram that had been given to us. We call this diagram as a multiple loop electrical network. Next, for the coding for MATLAB, I will give this part to Muhammad Shakir bin Najmi.
Based on this mechanical system in figure 1, the system should be in a mathematical model by finding the equivalent transfer function of G1 and G2. To find the equation, student must use all the variables that contains in the system related to cut 1 and cut 2, which is x1 and x2 as the output displacement. M1 and M2 is the mass, K1 and K2 is the spring constant of force spring. Fv for the coefficient of friction and also Ft for the force applied to the mechanical system. Then student will get the equation when one card is moved and another card is pulled and write it in matrix form. Line 4 until 10 used to generate to the unit step response, where student need to declare all the parameter value and define constants of the transfer function. Sims S and F are used as shortcut for constructing symbolic variables. The metric that used in the calculation have to rewrite into the MATLAB for the variables. Next, for A1, it is used to find x1 over f by changing the metric in first row into 0 and f, while A2 that used to find x2 over f need to change at the second row. After that, x1 and x2 can be found through the formula from line 24 and 26. Line 31 until 36 are used to command the transfer function of x1 over f, while line 39 until 44 are used for transfer function of x2 over f. Those commands include numerator and denominator that can create arrays of transfer function. As we can see from the board plot, this is proven that output response at figure 3 are x2 graph are higher until the amplitude at 2 compared to x1 until 1. Then both will increase constantly or steady state response. For coding part B will be explained by Muhammad Iqbal bin Murtaza.
For part B, first have to declare the value for every parameter, which is R1 equal to 1, C1 equal to 1, R2, C2, R3 and L equal to 1. Then student have to follow from the figure 2, which create an equation where the circuit is a 2 degree of freedom, and we can use the mesh analysis. So the process basically same as part A, but only use A2 to find the output of VL and required value of I2, where can get from the determinant A2 divided by determinant A. Lastly, the command in at line 29 until 34 help to obtain transfer function for VL over V. Based on the graph in figure 4, the amplitude are inversely proportional with the time. The board plot shown here is the output step response from transfer function for VL. Graph shows that data is decreasing at decreasing rate, then it increases until the steady state response at 0. As a conclusion, the relationship between the system output and its input is defined as a transfer function. As a result, a system unit impulse response is the inverse Laplace transform of its transfer function. Thank you so much for watching our video. We hope you will be satisfied with the lab result and video. That's all from us. Assalamualaikum.